Welcome to this video on measures of variation, part 1. After watching this video, you will be able to explain what is meant by measures of spread, calculate the range of a set of data, and calculate the population standard deviation of a set of data. You will also be able to explain why standard deviation is a more robust measure of spread than is the range. Let's start. What is spread? Well, sometimes you might think about making a sandwich and spreading some sort of condiment, maybe mayonnaise, mustard, ketchup, jelly, peanut butter, something on a piece of bread. So as you can see, the person making this sandwich just put a tiny dab in the middle of the sandwich. So this spread is not very spread out. On the other sandwich, you can see that it's much more distributed and it covers much more of the surface of the bread. So there's more spread here and there's less spread here. That's exactly what we mean when we talk about data being spread out or clumped together, except for, as you can see, the surface of the spread is in 2 dimensions, and when we look at a number line, we're only looking in 1 dimension. So if we look at this data set on this number line, all of the data looks like it's clumped together between 4 and 6. Over here, we can see that this data set is a little bit more spread out. Its range is from 3 to 7. So again, this data set in 1 dimension would have a smaller spread, and this data set in 2 dimensions would have a larger spread. The 2 main ways that we will learn how to measure spread are the range and the standard deviation. To calculate the range, you simply take the minimum value and subtract it from the maximum value. For example, suppose you have 5 different exam scores, 79, an 85, a 64, a 95, and 100. What is the range of these exam scores? Well, first we have to find the smallest or the lowest score, and then the highest score. In this set of 5 data points, the lowest value is 64, and the highest value is 100. So the range is simply 100 minus 64, which is 36 points. Let's go look at a sandwich example. So on the left side, we have a sandwich with just 2 dollops. Let's say it's, I don't know, some sort of green jelly. And on the right side, we have a sandwich that is much more homogeneously distributed, again, across the whole surface of the bread. On the left side, if we translated that into a single dimension, we can see that the range would be 7 minus 3, or 4. And over here, again, we can see that the range would actually be the exact same. It would be 7 minus 3, or 4. Now, hopefully we can all agree that even though the range of these two or these sets of values is exactly the same, the way this substance is distributed on the surface of the bread is not at all the same. So this kind of illustrates why range is really a weak way, or not a very robust way, of measuring or expressing how data is distributed or the spread of the data. Again, this only takes 2 data points into account, the maximum minus the minimum, and we really want a measure of spread that takes into account every single data point. So let's talk about standard deviation. Standard deviation is the average distance from the mean, or from the center of the data. If you remember nothing else about the standard deviation, please, please, please remember this definition. So since standard deviation is by definition an average, let's think about and remember, how do we calculate averages? Well, usually what we do is we add up a bunch of data, a bunch of numbers, and then we divide by the number of data points we have. And this is almost the same way that we calculate standard deviation, with a few important exceptions. So before I can give you the equation for standard deviation, I need to remind you about population and samples. So a population, remember, is every member of the population, right? It's every member or every data point that we want to study, that we're interested in, that fits our criteria. Whereas the sample is a proper subset of that population. This is important because there's actually 2 different formulas for standard deviation that are going to give you 2 different values. There is a population standard deviation, and there is a sample standard deviation. In Math 082, we are going to learn and use the population standard deviation exclusively. So there's probably a lot of symbols in here that seem unfamiliar to you. So let's go through this equation step by step and break down and interpret each of these symbols. So let's start with this symbol right here. A lot of times people think that it looks like an O, like a cursive O. It's actually the lowercase Greek letter sigma, so it makes an S sound. S stands for standard deviation. Okay. If you're wondering why don't we just use an S, well, the regular letter S is reserved for the sample standard deviation. So we had to steal from the Greek alphabet to get a different symbol for our population standard deviation. Similarly, for the population mean, we stole another Greek letter. This is the Greek letter mu, and it makes the M sound, so it stands for population mean. So a lot of times people think it looks kind of like a cursive U, but again, it's actually mu, and it would make an M sound if you were reading something in Greek. Then we have a capital N. Hopefully that's familiar to you. That is the population size. And then lastly, the last symbol that might not be familiar to you looks kind of like an E, like a capital E. It's actually the uppercase Greek letter sigma. And again, it makes the S sound, and it stands for summation this time. So it's not a variable, but it's actually an operator. So what it's telling us to do is take all of these differences and then square them and take each one of those and add them all up together. So that's what we're going to do. So let's figure out how to calculate the standard deviation. Chances are this equation, even though we just went through all the symbols, is kind of confusing and intimidating. So what we're going to do is we're going to learn to use a table to very simply and easily and hopefully somewhat quickly calculate our standard deviation.
Suppose you collected the following data on the number of tattoos that 5 people have. Calculate the standard deviation of this data set. So our data set is that one person has 3 tattoos, so I'm going to write that in this table. One person has 1 tattoo, then another person has 2 tattoos, one person has 0 tattoos, and one person has 1 tattoo. We're asked to treat this as a population, which means we have to use the population formula for standard deviation. You might want to take a minute, pause this video, and copy this table so that you can fill it in as we go through this problem. So the first thing we need to do is we need to calculate our mu. Remember, this is pronounced mu, this population mean here. And the way we do that is simply by adding all of our data points, 3 plus 1 plus 2 plus 0 plus 1. And then we need to divide by the number of data points that we're working with. Hopefully you can see we have 1, 2, 3, 4, 5 data points. So I'm going to divide by 5 there. So that gives me 7 over 5, which is 1.4. So in this column here for the mean, I'm just going to write 1.4 because the mean is the same for all 5 data points. Okay? So the next thing that we need to do is we need to subtract off the mean from each data point. In other words, ask ourselves, how far is this data point from the mean or the center of the data? So we're going to have 3 minus 1.4, that gives me 1.6. 1 minus 1.4, that gives me negative 0.4. Then we're going to have 2 minus 1.4, that's 0.6. 0 minus 1.4 is negative 1.4. 1 minus 1.4 is again negative 0.4. So this next step is where a lot of students get confused and make mistakes. So you really have to be careful about how you enter this into the calculator. So for the first one, 1.6 quantity squared, that's not so bad. That's going to be 2.56. Okay? The part where you need to be very careful is when you have a negative number. You need to have a scientific calculator with parentheses, and the negative sign has to go inside of those parentheses. So negative 0.4 times negative 0.4 is going to give you positive 0.16. In fact, all of these values are going to become positive because remember, a negative times a negative is a positive number. So be careful. And when you square something, in this case, okay, if you get any negative numbers, that means that you did something wrong. Something is off with your calculations. All of these values should be positive. Okay, so let's pause for a second and see what we've done so far. So if we look back at our formula, right, we have x minus mu squared, we have x minus mu squared. So the next thing that we see in our formula that it's asking us to do is this uppercase capital Greek letter sigma, right? Remember that means to sum. So what are we summing? Well, we're summing all 5 of these values. We need to add them all up together. Plus, 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 plus. Okay? So, I guess I probably don't need that last plus, huh? Okay, so when we add all 5 of those values up together, believe it or not, that gives us a sum of 5.2. So, I can replace this entire expression right here with the number 5.2, because 5.2 is the sum of the squares of the difference. Okay, so this is going to become, okay, so sigma equals the square root of 5.2 over n. Remember n is our sample size, n is 5. Now you can do one of two things right here. You can either just type this whole thing into your calculator and you will get about 1.02. Okay, if you want to do order of operations, then you'd have to divide first. So 5.2 divided by 5 is 1.04, and then the square root of 1.04 is about 1.02. The reason I'm rounding to 2 decimal places is because that's what we're told to do. It says round to 2 decimal places. So my final answer is 1.02. All right, let's do one more example. My next example says that we are counting the number of pets that 5 of our friends own. Okay, and once again, we are treating this as a population, so we're going to use the population formula for standard deviation. Again, pause this video, copy down the table, and then fill it in as we go through this. So one person has 5 pets, another person has, left-handed. Another person has 6 pets, one person has 4, one person has 1 pet, and another person has 7 pets. Okay, so just like last time, the first thing we have to do is we have to calculate our population mean. And we do that by adding up all 5 values and dividing by the number of data points that we have. And in this case, once again, we happen to have 5 data points. That's not always going to be the case, it just happens to be for both of these problems. Okay, so when we add all of these up, we end up with 23. Okay, so among our 5 friends, they have 23 pets. Then we have to divide that by 5. So on average, our friends have 4.6 pets. Okay, so we fill in this table, 4.6, 4.6. Okay, then we start the business of finding how far each data point is from the center. So we have 5 minus 4.6. Okay, that's 0.4. Then we have 6 minus 4.6, that's 1.4. Then we have 4 minus 4.6, that's negative 0.6. We have 1 minus 4.6, that's negative 3.6. And then we have 7 minus 4.6, and that is 2.4. Okay? So then we need to square all of these values, again, being very careful using our parentheses and making sure that all of those negative signs land inside, not outside of the parentheses. Okay? So remember, when you do that, all of these values should be positive. If you end up with a square that is negative, that means you did something wrong. You typed it into your calculator incorrectly. Okay, so remember, at this point, we now have 5 of these things right here. 5x minus mu quantity squared. So then our equation, just like last time, is telling us to add them all together. Okay, so we need to add these 4 values, plus, 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 plus. Okay, and when we find the sum of those, that gives us 21.2. So again, the sum of x minus mu quantity squared is 21.2. Okay, so I can replace this whole expression with the number 21.2. And then I have to come in and fill in the rest of the equation. Okay, again, n is my sample size, n is 5. Okay, so you can just type this whole thing directly into your calculator and you find that the standard deviation is about 2.06. You could also divide first. 21.2 divided by 5 is 4.24. And then you would take the square root of that, and that gives you about 2.06. Again, rounding to 2 decimal places because that's what we are asked to do.